Well, hello everyone. Welcome to this exciting session on green gas perspectives. We have now more than 80 participants. That's very good. Thank you for that. We are following up on the morning session, European time, where we already looked into some of the technical issues around renewable and green gases. And today we have more of a policy perspective, I would say, where we are and where we may go. And I'm extremely happy to have a wonderful panel here. There's one change in our panel, in our session. Malcolm McDonald couldn't come, so I took the liberty to replace him as far as I can. So you will hear from me not only as a moderator, but also as the last presenter on the European perspectives for green gases. With that, I would like to start and yield the floor to David Chiaramonti, who will give us the first overview of biogas, biomethane, sustainability of green gases. And you quickly introduce yourself at the beginning. Thank you.
Thank you very much, Uwe. In the meantime, I start sharing the screen. Good afternoon. Thanks for the invitation to join this panel. It's a pleasure being here. I have to introduce the topic, and I will also try to bring some ideas connected to green hydrogen in particular. Green gas, the topic we're discussing today is the use of biomethane or other derived gases in the alternative fuel sector. Natural gas has already a very important role at European level, but also in particular in my country, for example, where there's a larger share of natural gas vehicles already running across the road. It was some 70% of final energy consumption in transport from the roadside, and the biomethane potential is estimated to contribute significantly to that figure. Well, there are many ways to implement liquefied natural gas is a very important one, and this moves also ourselves. I hope to be connected because there was a electricity strike here.
Okay.
Okay, thank you very much for confirming. So maritime is also another sector that we all know is one of the priority sector, more difficult to electrify, more hard to decarbonize, that could be well addressed with bio LNG, with again a significant potential. The table below, overall, you see the different expected moderate scenarios from 2017 to 2030 in a recent paper by JRC. So indeed, this was discussed in many past occasions and in many past documents. This is the well-known document Clean Planet for All, in which you see that in the different scenario, anyway, natural gas still play a significant role at 2050. And it depends also on the member states that you analyze, and the role can change. There's eGas also coming in. The eFuels Alliance estimate a maximum of 5 to 6% contribution to overall demand in transport by 2030, which is a quite high target. That's to understand the overall scenario. Many scenarios have been published. Just a small remark that there's so many that we finally agreed with JRC to carry out a meta-analysis of these scenarios, and we examined some 56. This was pre-COVID, so probably we'll run other similar works in the next year. One remark from my side, to use very carefully this scenario, because very often the assumptions are not so transparent, and so it's sometimes difficult to understand or to frame the results of the study in this overall concept. While it is essential to understand which is the assumption behind a certain estimation. Another point I wish to remark is the interaction between production and supply. Actual supply goes through a dedicated supply system. In that case, as you see, Italy is very well placed in terms of refueling position for natural gas. But on the other hand, you have to cope this availability of fueling station with the number of vehicles. And when you combine these two pictures, you come out with such figures that are quite interesting from my side to analyze in view of policy making. These are 2018 and 2030 estimated, of course, situation for the second case. And this is called sufficiency ratio index, which is the ratio between vehicles and infrastructure available to refuel this. So the number of natural gas vehicles on the number of fueling stations. The two things to get an impact must go together. I was reading just yesterday on an European well-known website call for a more aggressive implementation of the infrastructure action at the European level to facilitate the distribution of alternative, sustainable, renewable or recycled fuel. So that's not to be undermined in our talk. Biomethane has a very important role in terms of GHG saving. It's well given in EC RED 2 Annex 6. Clearly, differences in this table also appear quite relevant depending on the technology, but particularly depending on the feedstock. And then we can add on this depending on how the feedstock is cultivated, for example, as primary crop or as rotational crop. But just to keep in mind that you can get to quite different results, even if overall, particularly if you deal with manure or with waste or residues, the GHG saving can be extremely high and sometimes even negative. I will come back to this in a moment. These estimations are not pretending to represent the state of the art. And I would say we are moving quite fast ahead in this type of process and technologies. It's continuously improving. So these represent conservative figures and they do not address the engine component they use, which is instead addressed in other studies like this one, the JAC study, well-to-wheel, that has also been published quite recently. I don't want to open the Pandora box of the CO2 regulation for vehicles that would deserve a proper discussion. Staying on sustainability, the interesting fact behind anaerobic digestion and biomethane from biogas is that is among the solution that can ensure even net negative emissions. It's one of the clearly possible way to get to carbon negative actions like biochar, for another example, or other systems like this. Again, it depends on the value chain and the feedstock or the way you produce this feedstock that your plant is connected to. But that's the strongest message I wish to deliver, that it can be done with this biogas biomethane route. It can be done in a decentralized way that is also important. So to distribute over the land the expected performances and impacts, and also the socioeconomic benefits connected to that, to the agroeconomy and rural economy. Another point that is hardly understood, or let's say is understood, but it doesn't deserve enough attention as it should have, is the fact that a fuel which is truly sustainable, which is high performing in terms of GHG emission, combined with the hybridization of a transport system like cars or trucks, is the most effective way to deliver greenhouse gas emission reduction. In this very nice study done by our colleague from Lund, in that case they are analyzing ethanol and HVO, but the message here is that recycled and renewable carbon fuel can really deliver high performance, better than purely battery electric vehicles in terms of GHG emission if you analyze the well-to-wheel. That's connected to the weight of the batteries that the fuel battery electric vehicle requires to carry out to be 100% electrical. So that's a message that should be taken into consideration. Also because this route is doable today with biomethane, with other sustainable biofuels, advanced biofuels in existing infrastructure and technology. Another issue that is connected to gas also from biogas is the hydrogen issue, which is on spot today in all European countries and beyond. Actually, hydrogen can be produced from many different routes, from the well-known steam methane reforming, or from the renewable side, from electrolysis using renewable electricity. But there's also the methane cracking or methane pyrolysis done in different way and from different type of methane, the fossil methane or the biomethane. There's also another route that is coming up at lower TRL, which is the aqueous phase reforming from bioresidues. And I'm thinking about the water phase of hydrothermal liquefaction, or some also water phase obtained downstream from solid separation of anaerobic digestion. These water dissolved organics can be converted into hydrogen. The nice thing of DMD, MPT, or biomethane pyrolysis is that carbon is separated as carbon and not as CO2, like it happens in SMR. Also, from the energetic point of view, there's a strong competitive perspective for this. And in the case of biomethane, you really get green hydrogen and carbon negative options through this mechanism. Indeed, TRL is moving ahead here. It's not yet probably fully commercial as anaerobic digestion, but is moving ahead quite fast. And I expect this in the next year will become a very relevant approach to the production of hydrogen. The interesting thing is that, you know, today we are between $3 to $4, mostly $4 per kilogram of hydrogen through the most explored routes, which is the electrolysis connected to wind PV electricity, and of course, the methane reforming. But through this way, several estimations already target the $1 per kilogram as a possible target. The reason, overall, many consideration that we could carry out here is the fact that we aim at valorizing two products, the hydrogen and the carbon. While in steam methane reforming, CO2 is an issue, then you have to connect to carbon capture and sequestration, and you, at the best, you can target carbon neutral and not carbon negative. In that case, connected to biomethane, you can really develop carbon negative, and you can valorize this carbon both as a product and as a carbon credit. So that's the reason why the possibility to achieve hydrogen production cost in the competitive range is real already today, even if there's still some technology development to be carried out. And with this, I'm going to conclude in the sense that gas can be among the most sustainable biogas, I mean biomethane, can be among the most sustainable options that today we have. It is ready for implementation. This is another strong point, because we must always frame the sustainability of a route in the timeline, in the time framework we have ahead, in the urgency to take action to decarbonize the emission, the transport system. So that's a real route that can deliver. Indeed, it must go hand in hand with infrastructure development and other policy elements like taxation and other non-technical barrier. So the two must be handled in a coordinated way. Biogas and biomethane have shown the relevance of the value chain approach. with this, I refer to rotational crops, to other carbon farming solutions that can be implemented in connection, and thanks to the presence of a digester in the primary sector, which is the agriculture upstream. This chain can be well connected with other routes like biochemical route or e-fuels or RCF. And concluding, it is indeed well placed into the recovery plan because it delivers also socioeconomic benefits in addition to the environmental benefits in a distributed manner. And indeed, the Fit for 55 package will also impact on the future development and the penetration of this chain. Because indeed all these energy markets are policy driven, and biogas is not an exception, and biomethane independently from the sustainability itself, but the market penetration depends on the policy that is developed as in place. So with this, I thank for the attention, and of course I remain available for questions if there are any. And I leave the floor to the moderator for that. Thank you very much.
Thank you, David. Excellent. You gave us a lot of thought, I guess, and maybe there will be a couple of questions reaching you later. So I encourage the participants, if something was unclear or if you want to comment, you can do the commenting in the chat. And if you have questions you want to be answered, you can do it in the question and answer section. David, you already referred that there's not just the environmental side, there are other sustainability issues, socio-economic components, and I'm very happy that Michela Morese will now take up the challenge to explore that a little bit and tell us from the broader perspective beyond Europe what's going on with green gases. Michela, you have the floor.
Thank you so much. Let me put the screen up. Thank you so much for the opportunity to intervene in these extremely interesting side event related to green gas in particular. And as Uwe was mentioning, I will give a global perspective. But allow me to introduce myself first. So my name is Maria Michela Morese. I'm the Executive Secretary of an international initiative which is called the Global Bioenergy Partnership. FAO is one of the founding partners of this initiative and also hosts its secretariat in the FAO headquarters in Rome, in Italy. So in the context of the experience of the Global Bioenergy Partnership, I will make a reference to the sustainability aspects that goes beyond environment, as Uwe was mentioning. So, as I mentioned, the Global Bioenergy Partnership is an international initiative. This slide gives you just a context, so idea of the membership of this global initiative. We have approximately 80 members between partners and observers, and you see on the screen between government and international organizations. USA and Brazil are the co-chairs. Well, since the very beginning in the partnership that started its activity in 2006, we have realized that sustainability was and is the basis of any bioenergy development. We are keenly aware that modern bioenergy could present excellent opportunities, but not without challenges. And throughout the years of the activities of the partnership, we've focused very much on sustainability in order to make sure that we develop bioenergy in a way that we would take out the best from the opportunities. And we've done so through the discussion and agreement on a set of 24 sustainability indicators that you see on the screen. Of course, you only can see the titles of these indicators, but you recognize that those 24 indicators are equally subdivided under the 3 pillars of sustainable development: environmental, social, and economic. And these wants really to be a very strong political message by the GBAP initiative in terms that sustainable development of bioenergy can only be achieved if equal importance and equal attention is paid to the pillars of sustainable development: environmental, social, and economic. These indicators could be applied to any type of bioenergy on a life cycle assessment approach. So it means on the whole value chain. And the objective, the final objective of the measurement of these indicators is, on one side, to develop a sustainability assessment and understand where the sustainability could be improved or where the performances are good enough. On the other side, these data are transferred, once measured, they are transferred to policymakers in order for them to take informed decisions and improve, therefore, the sustainability of the national bioenergy value chains. Even more, if measured over time, of course, information to policymakers improve in terms of giving to the policymakers additional suggestions on how to further improve the sustainability of their bioenergy value chains. And this is the core of the report that contains the 24 indicators, and of course, for each of those indicators, a full methodology to guide experts in their measurement. Well, I don't want to go into details of how many countries have already implemented these indicators, but of course, these scores could give you an idea of the many countries that have implemented these indicators so far, and the level of commitment by governments and by GBEP members and beyond. So the four green covers that you see zoomed are reports of the measurement of the GBEP indicators that were performed by FAO, by the GBEP team in FAO, in Colombia, Indonesia, Vietnam, and Paraguay. And in those four countries, we have analyzed several bioenergy value chains, but I will focus on Indonesia and on Vietnam in particular, because biogas was one of the main bioenergy value chains we analyzed. I will start with Indonesia. As you may imagine, one of the bioenergy value chains that we analyzed was the palm oil one. And we, at the end of the assessment, we realized that, of course, we know that the production of palm oil produces large amounts of waste, which is called palm oil meal effluent, POME. This waste, this effluent, is usually left in ponds, and you see the picture on the screen. And the composition leads to methane emissions, in very significant amounts, and is also contaminating the surrounding soils and waterways. So in this aspect, we realized that in terms of sustainability, a lot more could have been done in the country in order to have different waste management technologies in order to also generate energy. And in particular, the idea, of course, is to have a methane capture system of the palm meal effluent that can be used to produce bioenergy, biogas in particular, for example. But we also realized that this was put in place only in less than 10% of the mills in the country. These are data related to 2014, but I wouldn't expect let's say an extraordinary difference percentage of methane capture systems today in the country. So in this case, the waste management of POME would have brought to many positive aspects that are, of course, methane capture systems to reduce GHG emissions, to reduce soil contamination, to improve water quality, and to enhance access to modern energy services, of course. So this is one concrete example of the added value of biogas that could be a very sustainable source of energy, and even more if we consider that it could be created, be developed through a good management of wastes that otherwise would have been left into the soil and emitting methane. Another example comes from Vietnam. In this case, we analyzed the biogas value chain from households and livestock farms. In Vietnam, the anaerobic digesters are very prevalent in terms of biogas in the country. Mostly biogas is used as a clean energy for cooking, for heating and lighting, and of course to displace traditional biomass and fossil fuels, and it presents multiple benefits. For example, it facilitates the reduction of household expenditures on energy, and this is related to indicator 11 between the set of the 24 indicators that I mentioned before. It facilitates the increased access to modern energy services, indicator 13. Reduce instant collecting for fuel wood otherwise. It reduces exposure to indoor air pollution that would have a negative effect in terms of respiratory diseases. And also it implies the possibility to have skilled jobs. Here, this gives you an idea of the biogas production from pig manure mainly, and from also cassava wastewater in the country. And see also the different scales of the farms. Well, in the country, in Vietnam, we have realized that the main challenges we identified further to the measurement of GVAP indicators through the sustainability assessment we implemented. Main challenge was, on one side, the lack of capacity. The lack of capacity of farmers in terms of poor management of the anaerobic digesters that was reducing the efficiency, of course, of biogas production. For example, there were some cases anaerobic digesters with many cracks leading to biogas leakages and therefore reducing the efficiency, or farmers adding too much water into the digester and therefore watering somehow the digestate that would have reduced again the efficiency and therefore also difficulty in transporting then the digestate into the soil fused as an organic fertilizer. So in this case, the recommendation from our side was to improve the design, the construction of anaerobic digesters, and also provide capacity development for farmers. The second main challenge that we analyzed was the lack of capital. Lack of capital, not mainly for the production, for the construction of the anaerobic digester per se, but lack of capital to buy generators to transform biogas into power. And this lack of capital bring the country and the farmers to deliberately do venting or flaring of the biogas which is in surplus, with all the consequent GHG emissions that we may imagine. So in this case, the recommendation was to promote power generation from the use of surplus of biogas at the farm and also at the industrial level, and possibly the establishment by policymakers of microfinancing schemes to support the installation of household anaerobic digesters. Well, in addition to these experience in Indonesia and Vietnam through the measurement of the GVAP indicators, in the context of the Global Energy Partnership, we've also developed a stocktake report, which is an overview of regional experiences on biogas value chains. And we've also, so this is the cover of the report that was published in April 2000. And we also developed a series of webinars to exchange the lessons learned and the best practice that are contained into this stocktaking report. And this series of webinars in 2020, you see, we organized 3 webinars in May, June, and last September. So I would like to focus on the stock-taking report and on the results that we take out from the stock-taking report. This report was developed through analysis in the 3 continents, Africa, Latin America, and the Caribbean, and Asia, during a 3-year process in connection to the GBEP Bioenergy Weeks that were organized in Ghana in 2017, Argentina in 2018, and in Manila in the Philippines in 2019. And we used the SWOT analysis as a basis through interviews with key experts in the biogas sector in the various countries, in the various regions. It's interesting to note that we ended up across the regions with very, very similar conclusions regarding the opportunities and challenges of biogas. So the positive factors that we assessed as a result of the Stockton report was the use of co-benefits of anaerobic digestions that are extremely important. So for example, the use of residues and wastes, the possibility to have improved waste disposal, the use of digestate as an organic fertilizer, etc. The negative factors that we assessed, that we realized that were common to all the regions analyzed, were the high initial investments for the anaerobic digesters. That was a similar condition, a similar challenge in many countries throughout the regions, together with the poor knowledge of constructions and management of the anaerobic digester. So you see exactly similar situation also to the case of Vietnam that I mentioned before. And all these kind of conclusions, positive and negative, brought us to conclude that with very important recommendations in terms of need of robust and dedicated policies, very clear policies from policymakers, and also investing on trainings that are key in order to uptake the use of bioenergy throughout the world. So I hope that with this I've given some food thoughts for the discussion to follow, and this is a family of the GBEP family. Thank you so much.
Thank you, Michela, for bringing us to the broader scope of the issue. I think that's the mentioning of the co-benefits is quite important for the sustainability discussion, not only in the sense of the environmental ones, but clearly the socio-economic. I personally had the experience in Africa that there is a good opportunity for biogas also to consider the deforestation issue, because you have different cooking fuels. And that is something which really is a concern for many of us. Anyway, that was really, really great. I appreciate that, and your presentation will be available so people can duck into some of the reports. And it's also very nice. I can use my IEA Bioenergy hat now to say that the work of the GBEP on the biogas nicely complements the work from the IEA Bioenergy task on biogas and task 37. And there's some collaboration. So hopefully this will flourish further for the benefit of all. Before going to more regional perspectives, I would like to call up a poll. So now you have work to do. We are making one poll which asks a simple question. When you think we want to foster renewable gases, what are the best ways to do so? You have the opportunity for one choice, and I'd be happy to see what you are doing. We are coming then back to the results when we enter our discussion phase of the panel. So please make your choice, and it's easy to do. And we continue, while you may want to consider this short question, with our next speaker, who brings us to China. And Ms. Dong, I invite you to give us your presentation on green gas in China. Thank you. You have the floor.
Thank you very much for the introduction. And today my talk is on the green gas development in China. And I always start from this slide to explain the strong correlation between the energy consumption and the economy and the emission. So the historical fact, it told us that with a greater economic increase will cause a very big emission. This is the historical result. But nowadays, we need to shift to a green way so that to reduce the emission intensity. And this is the fact. On the right is the fact. So you can see here's China, and China is really going to the peak of the emission. And we can imagine that the emission can be reach the peak by about 2030, as promised by the Chinese government. And then the emission will become the zero or neutralized around 2060. But to realize the carbon neutralization, we need energy transfer. The energy reform. So we need to build a renewable energy based energy system. And the solar energy is the largest renewable energy. And so from the photosynthesis, it will produce the biomass, and biomass can be used to produce a biogas, or to through the gasification to produce the syngas. On the other side, the solar energy through the PV can produce electricity, and then to produce the green hydrogen. And the green hydrogen, the syngas, and the biogas are three main green gases nowadays. So China is one of the most successful country for the biogas development. When the new China was set up, the founder of New China, Chairman Mao, he emphasized the importance of the biogas. And since then until now, the current President Xi Jinping, also he increased the use of the biogas technology, and he said he pointed out that to use the biogas technology to treat animal manure to produce the biogas and to produce the biomethane. Not only the manure could be the feedstock, but also the crop residue or the kitchen waste and some other agricultural bio-waste. All the agricultural bio-waste can be used as a feedstock to produce the biogas. And this is the reality in China. We can only use the waste. We can only use the waste for the biogas production. We cannot grow the maize to produce energy. No food, no feed for fuel. So this is China situation. The biogas developed from the Hosgood small-scale biogas tank. This average size of range from 6 to about 15 cubic meters each, and you can see the Hosgood biogas plants developed very fast. But nowadays, around 20 years ago, the small-scale biogas plants number decline, and the size becomes larger and larger and larger. Nowadays, until 2 years ago, the large and medium-sized biogas plants number reached to about 100,000. And here is a national standard to categorize the biogas plant from the small one to medium to large and to super one. This is a data. I analyzed the published data, and we found in 2017, that's 4 years ago, each province of China, this is the biogas production per year, and the lower part is the average productivity of the biogas plant per cubic meters of the biogas plant per day. And this is about 300 to 400 liters of biogas produced. So compared to the European data, this data is is pretty low. It's much low. That means there will be there is a bigger space of the technology improvement in China. From last year, China have the carbon peaking and carbon neutralization strategy, and we know that if we want to really reach the carbon neutral environment, we need to have a carbon capture and carbon storage technology to really take the carbon dioxide from the air and store somewhere. So we call that the CCS. And very lucky is that our bioenergy sector find that with the bioenergy with the use of bioenergy, the carbon capture and storage will become much cheaper. But even much cheaper, but the cost is still very high. It's around $300 per ton of carbon dioxide equivalent. But without the bioenergy, the CCS is too expensive. But if we come back to look at the biogas technology, we will find a surprisingly new way. This biogas-based carbon capture and storage. So we collect all the feedstock to avoid the emission and to produce biogas to generate negative emission because we replace energy, and then the digestate to be returned into the soil and nutrients to be used to replace the chemical fertilizer, and it also generates negative emission. And later, the organic carbon in the digestate will return to the soil if we have a good land management. So the organic carbon in the soil will be fixed, and that create the further negative emission. So just a good combination of the digestate application into the soil together with the land management will really generate a big negative emission without a high investment, without high cost. So this is a new type of BECCS. And this is one factor to drive the biogas development fast, to develop fast in China. And the second factor to drive the biogas development in China is to use the biogas plant as a backup of other renewable electricity. For example, the PV or wind turbine, the PV and wind turbine can generate electricity a big amount, but it fluctuates. And the biogas can be a backup, cannot to back up 100%, but can to some certain extent. So this is the biogas plants development in China, the two new driving factors. And in fact, in the South China, there's really a biogas plant. They produce biogas, store that during the daytime, and during the night, they produce electricity to compensate the PV electricity during the daytime. Okay, so that's why in China we say in the new decade from the 2021 to 2030, this is the new decade is very special for biogas engineering revolution. The revolution means firstly to turn all the bio-waste into the biogas first, and then after the biogas fermentation, so the digestion, you can do the composting, you can do the gasification, you can also return directly into the soil. The second is that the solar energy to biogas, solar energy to electricity, and electricity to the hydrogen to combine with the carbon dioxide to produce methane. So those at least the two ways we can try as a biogas engineering revolution in the new decade. Here's a prediction of the biogas production in China. By the 2060, there will be about 50 billion cubic meters of biogas from the crop residue and 70 billion from the animal manure. So that is a huge amount. Just compare that the 50 to here, just only 0.2. So the current situation is very, very small, and when we have a new mechanism to promote biogas development, we can expect a very big biogas production. Okay, for the syngas, the technology is very mature, but in China we face a big problem, that challenge, that how to collect all the organic things into one station to produce a huge amount of syngas. So that's the challenge. But nowadays we have about 500 village scale, the small scale syngas station to produce syngas for the farmers' use. And for the hydrogen is a very hot topic in China. I just want to give you several examples that for this year. So this year, the first hydrogen stock on the market. And then the second example is about 10% of hydrogen can be mixed into the natural gas system for the end user, for the end use. And number 3 is just 2 days ago, we announced a huge project, 10,000 tons of hydrogen production project. It just launched 2 days ago in Xinjiang province. So we can, yes, for the hydrogen, there are some already still some uncertainties or challenges, but with the technology innovation, so we can find a brighter and wider use of the hydrogen. The number 4 for the green gas development in China is the standard system development. And in China, they are already about 40 or 50 standards for the biogas plants related. But now I need a team to study that, to do the research, try to restructure the biogas standards. And the carbon neutralization standards is just a start in China, and hydrogen standards focus on the production, storage, transportation, and application, and especially the safety and risk. So this is the standard. Okay. Until now, this is the green gas situation in China, and I'm from China Agricultural University. I don't want to explain too much, but we have a National Center for International Research, international research of bioenergy science and technology, and this is my team, and this is the research facility. So we are looking forward to working with all the colleagues in the biogas area and in the bio waste treatment for energy and fertilizer direction. So thank you very much.
Thank you very much for giving us really, really interesting insights in the dynamics of biogas and even hydrogen in China. That is very encouraging. Also, that China is now part of IEA Bioenergy. We were very happy to welcome you in our small family. I think there will be lots of exchanges. The next step will be to look to a very different country, to the United States of America, where biogas was nearly not that much high on the agenda, in my impression, seeing it from Europe. But I'm very happy that Sam Lehr will give us the insights of green gas in the United States. Sam, you have the floor.
Thank you. Good morning and good afternoon, everyone. And thanks to the IEA Bioenergy team for putting on this truly comprehensive and timely conference, and for inviting us to speak today. My name is Sam Lehr, Manager of Sustainability and Markets Policy at the Coalition for Renewable Natural Gas. And today I'll be providing you all with an overview of the policy picture surrounding biologically derived renewable gases in the United States and Canada. Next slide, please. At RNG Coalition, we represent over 300 members throughout North America, advocating for the development and use of RNG, renewable hydrogen, and biogas produced from all sustainable feedstocks, created by all sustainable and competing technologies, and for all sustainable end-use applications. Formed in 2011, our focus has historically been on the use of anaerobic digestion to produce RNG, but our work has been expanding to encompass an increasing number of emerging technologies in the bioenergy space. Next slide, please. Broadly speaking, we know there is a significant value in the use of biologically derived feedstocks across sectors. This includes the use of RNG and increasingly electricity and renewable hydrogen as a transportation fuel for corporate and industrial clean energy buyers and utilities alike. And given that bioenergy provides the only pathways to carbon negative energy, especially when dealing in methane mitigation and in tandem with increasing carbon capture and storage technologies, our industry presents a unique value proposition, as you all know. And so we've seen significant interaction within the anaerobic digestion industry between these types of partners. For example, those who are concerned with the carbon footprint of their waste, seeking anaerobic digestion as a solution, and pairing that with renewable energy needs in, for example, the higher education sector. And that extends really to a number of feedstock, to energy carrier, to end use applications that you can imagine. Next, please. One of the reasons why this is such a crucial time for our industry hinges on the need to shepherd in a new generation of waste management technologies, which from a climate standpoint will necessarily be focused on methane emissions. As we all know, this year's IPCC report was very clear on this topic and included methane capture and recovery from solid waste management as an important strategy. We've also seen explicit commitments from the UN to reduce methane, which in the US has taken the form of a pending methane regulation from the Environmental Protection Agency. This rule includes reducing leakage and venting from oil and gas operations, increasing the landfill gas capture rate to 70%, and rewarding emissions reductions in the agricultural sector. And so here's where we really see an opportunity for our industry to live up to its potential in abating methane emissions, which is a mantle that we've been carrying really for years now. Next, please. Pursuant to that goal and to the goal of realizing a sustainable profile for organic waste more broadly, including improving human health impacts and the circularization of our economy, RNG Coalition has established our Sustainable Methane Abatement and Recycling Timeline, or SMART initiative, in which we aim to capture and control the methane produced by all 43,000 aggregated organic waste sites in North America by 2050. Next slide, please. In addition to the methane pledge, we're currently in the midst of some unprecedented developments for climate within the US federal government via the Build Back Better Act. Having passed the US House on November 19th, this legislation is currently under consideration by the US Senate, where the thin margin from a party standpoint will necessitate a compromise between the progressive and center factions of the Democratic Party. This means that various provisions are still at risk of being cut, particularly for the purpose of reducing the overall cost of the act, which has been a target of both Republicans and some moderate Democrats here in the US. But importantly, as currently written, there are three key provisions which would be very beneficial to our coalition's mission and members. These include a biogas property tax credit, which would allow cleaning and conditioning equipment to qualify under the Section 48 Renewable Energy Investment Tax Credit, which can apply to project owners or investors. A new clean hydrogen tax credit, which is technology neutral, allowing for the use of RNG as a qualifying feedstock and rewarding different types of hydrogen based on the level of greenhouse gas reduction. A lowering of the threshold for the 45Q carbon capture and sequestration tax credit, and an extension of the 50-cent alternative fuel tax credit. Next slide, please. In addition to these federal developments, there have been a flurry of legislative and regulatory developments related generally to policies which promote decarbonization and clean fuels on the state and provincial levels throughout North America. One of the strongest policies for our industry has been the Low Carbon Fuel Standard, also known as the Clean Fuel Standard, which was first implemented in California and has driven substantial growth in the RNG industry. Notably, Washington State passed legislation this year, which began the implementation of a clean fuel standard. Operating in tandem with state and provincial level programs in California, Oregon, and British Columbia, this move completes what has been coined the Clean Fuels Coast. This is a very significant step, as RNG Coalition has been actively working on supporting a Washington clean fuel standard for years. Outside of the West Coast, New York remains an important state where a clean fuel standard has been considered for some time and a leading state to look to on this front in 2022. Minnesota is increasingly drawing attention as a Midwestern leader, which is looking to pass a CFS, having introduced the Future Fuels Act last year in the state legislature, which is slated for reintroduction this year. New Mexico, which would be the first oil and gas state to enact a clean fuel standard, saw a big bill make significant progress last year and remains on the radar for 2022. And finally, Canada is currently working on the regulatory side on implementing a clean fuel standard at the federal level. So these policies are important because they've really been the largest driver for our industry in terms of incentivizing methane mitigation and supplying renewable natural gas for use in natural gas vehicles. And as we look ahead, we expect pathways for RNG to electricity and hydrogen to increase under these programs when more fleets begin to adopt these zero emission technologies. Next slide, please. In addition to the transportation sector, RNG is being increasingly looked at for applications in stationary sectors, which are currently served through natural gas pipeline infrastructure, including heavy industry, electricity generation, and direct procurement by energy utilities, as illustrated here. There is immense diversity among these existing and emerging state level programs, but as you can see, regulations to enable RNG are being enacted across North America. Next slide, please. The bills listed here are just a few legislative highlights from the past year, which will enable RNG procurement by utilities. So first, we have the Natural Gas Innovation Act in Minnesota, which would allow gas utilities to file innovation plans with their Public Utilities Commission, including cost recovery of up to 5% of the utility's annual revenue requirement. And this program is particularly significant because it allows for RNG, electrification, electrolytic hydrogen, and energy efficiency, among other resources, as complementary decarbonization strategies for Minnesota's gas sector. So we think this is really a model legislation in the US for gas sector decarbonization. Comparatively, we have Michigan SB 138, which will require the state's Public Utilities Commission to conduct a study of RNG potential in Michigan. A study bill such as this is often a good first step for RNG policy in a given jurisdiction with an eye toward future development. And finally, we have Colorado's SB 21161, which was originally designed to enable gas decarbonization through the setting of RNG targets, but ended up being reintroduced and passed with some changes, making it a clean heat bill with a less attractive RNG carve out. So while this Colorado legislation is still helpful to the industry, shows some leadership on RNG within Colorado, it sits in juxtaposition to the Minnesota bill, which is really the most enabling and comprehensive that we have. Next slide, please. Additionally, it's important to highlight the developments we've seen in support of voluntary RNG procurement, that is for RNG purchased outside of a low carbon fuel standard, portfolio standard, or other mandatory program. So under Center for Resource Solutions Green E program, which has long served as a flagship for renewable electricity procurement, a new arm was created this year, which is focused solely on renewable fuels. The Green E RFS, as it's called, Renewable Fuel Standard, is the first sustainability certification for RNG in the voluntary market and has the potential to substantiate sustainability claims made by corporate entities or other voluntary buyers, such as those included under some gas utility programs who purchase RNG. And we expect this to be extended to include renewable hydrogen and any other renewable gases in the future. Next slide, please. Finally, I've outlined here some key directional considerations with an eye toward the future of our industry. So to start, it's important to consider how RNG and other bioenergy resources can ultimately move toward full carbon neutrality, or more likely, carbon negativity on a life cycle basis. The three main contributing factors are electricity and fuel used in upgrading and transport, and in the second bullet, any methane leakage during upgrade and transport. So by using 100% clean electricity, biogas as a fuel during upgrading, reducing leakage as much as possible, and employing carbon capture, there's a clear pathway for these resources to attain a carbon negative profile across our industry. And very importantly, in item number 3, how do we continue to use these waste-derived energy resources to improve conditions across the waste management industry? So waste-derived bioenergy, again, presents a huge, unique value proposition in that we are part of the climate and broader environmental solution across the waste and energy sectors. However, poor organic waste management in some cases has been incorrectly used against these energy resources. So how can we better quantify these ancillary benefits that we facilitate, and what can we standardize to make sure that such improvements are widespread and as far-reaching as possible? Next slide, please. So for any questions from the audience that we may not get to today, please feel to reach out to me by email or phone as provided here. And with that, I'll turn it back to you, Yue. Thanks.
Thank you, Sam. That was also quite encouraging to see the North American view. Lots of dynamics in the policy segment. I guess that's encouraging. And now I would like very briefly to turn to Europe and see what's going on with green gases. So you see a few slides from my side. It's not comprehensive, but it gives you some good sources, I hope. And with that, let me share my screen that you may have an opportunity to take a look to what's going on in Europe very quickly. I'm actually a scientific director of INAS, a small international institute dealing with sustainability. And I'm also leading Task 40 in IEA Bioenergy and co-leading Task 45 on sustainability issues, just that you know. Renewable gases, we already heard about biogas from various substrates, about biomethane, which can be produced from biogas. We have heard a little bit about renewable hydrogen, especially thanks to David. We already heard about pyrolysis, the cracking of methane, which gives us a solid carbon option. And we have the renewable methane, which can also come from boostering the biogas side. The methanation can also be quite an interesting thing. So we talk about also renewable methane from renewables or from a combination with biogas. I think that's quite a nice spectrum of activities. The sources for what's going on in Europe, I just want to direct you. You will see the web links on the next pages. We have an annual, what we call the barometer for biogas in Europe, fortunately, quite interesting to see for each country in the European Union. You see the dynamics here, and in the moment, it's quite encouraging. Just a few days ago, colleagues from IEA Bioenergy Task 37 released an interesting overview of renewable gas. And in a few weeks, we're going to have a special project from IEA Bioenergy on renewable gases with a focus on hydrogen in the grid, where the issue of infrastructure and the possible uses will be focused. It also gives a broad overview of all the hydrogen strategies and national programs around the planet. So stay tuned for that one. In Europe, we have pretty much all countries participating in biogas and biomethane for various markets, electricity, heating a little bit, and also transport fuels. And you see here by the circles in the size that the Germans, the British, France, and especially Italy are dominating these markets. All the other countries also contribute, don't worry about it. And it's quite nice to see that, as I mentioned, all member states of the European Union are quite active and giving their agricultural systems, waste systems, and so forth. You will see different amounts and also to what extent they have started doing so. The overall biogas and biomethane production in billion cubic meter since 10 years ago, you see we have a dynamic growth up to the last couple of years, and now it reaches something like a saturation. And one reason for that is clearly there are more competitive alternatives on the electricity side. We know about solar and wind dynamics. On the other hand, we had, I should say, a rather stable gas prices in the European system. So it was not that attractive anymore. But with the rise we see in these months, I guess people will turn their attention back much more, especially because there's really, really a high potential for that in Europe. If we look to the trade between member countries, this is just a snapshot where we see on the continental European part, we trade a lot around Germany and Denmark, but we also have Switzerland here, and we also have the UK as providers for biomethane trade. And the flows are still, compared to electricity and natural gas trade, comparatively low in the percentage range, but it's growing. And the more we establish a European renewable gas policy, the more trade we can see that also includes certification and tracking in terms of mass balances that you're not double counting. So I think that's what we see nowadays, that with the European gas regulation being under revision, we expect that there will be a strong component on hydrogen, but also on biogas and biomethane, allowing more trade between countries, but also the domestic deployment. And fortunately, with the recovery plan we have also here in Europe, there are very, very good options for investments over the next couple of years. And with the benefits we heard about from the previous speakers, I'm pretty sure that the European biogas, biomethane, and hydrogen family will continue to extend the green gases quite a bit. Now, just one thing regarding the hydrogen, the green hydrogen, I should say. We're not talking about gray or blue. Today, we have some countries and regions where biomethane is fed into the gas grids. That's what you saw through the trade picture before. We see in the next couple of years that we will have these regions continuing doing so, but there will be others coming in with something up to 20% of hydrogen production being fed into the existing gas grids, both for the distribution, less so for the transmission, less so for the distribution. But some countries are experimenting in Europe, and we give an overview in this paper I mentioned at the beginning. And some countries and regions will start with 100% regional supply. That's what we call local valleys or hubs for hydrogen. After that, we will get a phase about 10 years from now where more of these backbones will be considered. That means 100% hydrogen supply. And the mix of the regions will continue. And in the 2015 perspective, we see that there is 100% renewable gas being produced, and that biomethane continues to participate in that game. But now the infrastructure will be adjusted to also absorb more direct 100% hydrogen. Now here exactly is one of the issues we are not yet sure about. What you see here is the vision from the gas industry in Europe. But there are alternative visions which argue that on the one hand, direct electrification will bring down the gas demands, and up to 2050, it may be problematic for some regions to maintain their revenue from the gas infrastructure, especially not refurbishing. So that's one issue, and there are other thermal alternatives, including energy efficiency for buildings, which could rapidly bring down the demand from housing. On the other hand, we also have biomethane increasing, and it could be blended, as mentioned, through the methanation route to bring renewable hydrogen into power to gas. And we can convert the hydrogen into methane, into synthetic methane quite nicely, which can be stored and is 100% compatible with the existing infrastructure. So here there is a game open. In our report, we raise this as an open question where we don't know beyond 2030 to what extent we really need massive conversion or actually new pipeline systems for hydrogen, dedicated backbones, or couldn't we more organically move into the renewable hydrogen and methane world? That depends on many factors, and it will be interesting and possibly even exciting to see that. I would like to underline what David mentioned at the very beginning, that the Europeans are now also looking in a more integrated way into their energy systems. So it's not just that we have electricity and gas and heat and transport. We are looking to the interfacing between those, and that's where renewable gases can play a major role in terms of balancing, flexibility, and storage. And I think that's quite exciting to see that there's a merging of these separated sectors. But again, the policy to actually bring this merger into existence is not yet there. We have ambitions from the European Commission. We have interesting plans from some of the countries, especially countries such as Denmark and the Netherlands, Italy. But the practice to actually lead us into that way in terms of policies needs to be yet done. So the next couple of years, including the European gas regulation, will be quite exciting. And we are always looking to other parts of the world, what the US, what Canada is doing. And clearly the greenhouse gas component, the decarbonization, will be a major driver in that. But the regulatory thing to actually allow investments and recovery of the cost, and hopefully also some profits, that needs to be seen, because we have the existing gas system with existing interests, and to what extent this conversion, the transition, will happen in a way as you see on this slide or not is an open question. With that, I would close, and hopefully I have put your interest on the European side. We have lots of data available in these reports I mentioned, but the strategic issue in terms of green gas is we still have to do our policy work. It's not yet done, and the Commission will hopefully soon publish proposals for that. So over the next couple of years, we have an intense debate about that. And with that, I would like to close the presentation part, and we're gonna enter our discussion part, where we try to answer your questions, and we hopefully get more from your side. And before doing so, we hopefully see the results from our poll we did about half an hour ago. Marco, could you show? Yes, thank you. So you see this brief question, one of the earlier options to say, let's phase out natural gas applications. That only has a minority of supporters. In the medium, we see green grids, the gas grid, greening the gas grid as an option, and to do both, which is quite sensible, has the majority. So thank you for that. I guess we are in a good shape here, that we don't want to phase out one or the other special use, but to convert and make this transformation of the gas system towards greener components and uses. Thank you. So I invite my fellow panelists in this session to switch on their cameras so that we can have the remaining about 45 minutes to look into some of the questions and get your answers to that. And let me start with the one question which came up quite often in the Q&A session. That is, what are the main hurdles, the obstacles we see towards a more deployment of renewable gases? And I would start with Michaela, ladies first, giving us a global view from your experience. Where do you mentioned already some constraints you found. Maybe you can just highlight that again. Thank you.
Thank you so much. Yes, indeed. Well, in the stock-taking report that we've developed, we have realized how much similar challenges and opportunities are throughout the world in different regions regarding challenges and opportunities of biogas. So in particular, if we think about the economic challenges, of course, as I mentioned, the cost of an anaerobic digester extraction is an issue. The cost of buying generators to avoid gas flaring, gas venting with the surplus of biogas, and instead using the generators to produce electricity, it's another challenge. In terms of social aspects, of course, the training, the capacity of farmers, in particular, if we think about smallholders, if we think about rural areas, where, of course, the capacity of farmers to construct, build the digester, the capacity to maintain the digester. Sometimes, as I mentioned, there are cracks on the digesters that leads to wasting, biogas, or farmers that tend to put too much water into the digester instead of the required limit, which brings to too much watered digestate, which is then less efficient in terms of biogas produced, and it's also less efficient in terms of how to transport these digestate into the soil if it's used as an organic fertilizer. So training, I would say, is the main social challenge throughout the world.
Thanks, Michaela. I would continue with Mr. Dong from China. Major obstacles. We saw the interesting plans and scenarios for the future up to 2060. And let me just add one question. You may be able to answer that from the questions and answer session. Is it just internal combustion engines, generators, which can convert green gases into electricity, or shouldn't we also consider fuel cells? So a very different opportunity and a much higher efficiency. Is it something you also have under consideration? You got the floor.
So thank you for this question, and I think that the fuel cells for the electricity production from the biogas or from the biomethane is still in the laboratory. I don't think it's it is the time to put into the market now. So yeah, from the experience in China, we still use the internal combustion generator to produce electricity, to convert the biogas to electricity. There are some researches in the university or in the academy, but all the things in the laboratory, or I don't think it's put onto the practical use. And I would like also to add something to the obstacles or the technical, economical obstacles for the biogas development. Maybe China, the situation is quite different from Europe. We need to know nowadays is a very special time for the Chinese experts to rethink about the biogas, to look at the biogas from the energy point of view or environmental protection point of view. In the past, we mainly think about biogas from the environmental protection point of view. We always say, okay, anyway, the biogas plant, you should use that because you need to use that to treat the manure or treat the bio-waste. Otherwise, you cannot find a cheaper way. So the biogas technology is the most cheap way, the cheapest way. Even it is very expensive, but it's still the cheap way. But this kind of a statement cannot really attract the investment from the big money, from the big companies. So from now, we try to lead the society to look at biogas from the energy point of view. So this is the energy. Yes, from the agricultural bio-waste is not big enough to produce too much energy. Let's say 20% of the total energy. This is very difficult. But the biogas, just as I explained, the biogas is a compensation of the other renewable fluctuating renewable energies for that. So this is will attract the big companies when they really invest a huge money for the PV or for the wind turbine. But we explain to them that, okay, if you invest a small amount of money to do the biogas in the same region, then you can have a larger capacity, or you can expand your PV capacity. Then that is an attractive factor to the very big companies. So yeah, just an angle from the very recent research.
Thank you so much. I would like to just hear from Sam. You already mentioned some of the policy dynamics in the US, and we are very happy to have the US joining us again in the climate game, if I may say so, and also in green deals coming up with quite some money. What's a major obstacle from you? Again, this question, and do you have the same perspective regarding fuel cells? I was aware that some of the US utilities already operate a lot of fuel cells for peaking and so forth. Is it something you may want to comment as well before we come to David?
Sure, yeah, thanks. So I think probably the biggest hurdle in the United States is stakeholders that are involved in clean energy transition conversations, not having a full understanding of bioenergy generally and the technology behind it. I think, there's, like we've all mentioned, there's a lot of potential sustainability benefits, especially when you're talking about waste to energy, right? The idea that we could transform our waste management sector in the United States using, in part, some of these technologies, I think deserves a lot more attention. And the other issue is that the difference between biogenic carbon and fossil carbon, I think is really still lost on a lot of folks, which, is really important. And as we all know, is what enables us to be a carbon negative industry over time. So really, I just think it's still an educational hurdle in a lot of ways. But that being said, our industry in the United States, from the renewable natural gas biomethane standpoint, we passed the 100 facility mark in 2019. And I believe by the end of this year, we're going to pass the 200 facility mark with many, many projects still in development. So we are seeing rapid continued growth that we've never seen before in the sector. In terms of fuel cells, that's definitely an option that's on the table. I know we have members of our coalition who work squarely in the fuel cell space, and they're looking at both fossil natural gas, renewable natural gas, and also hydrogen for those applications. So I think the technology is still relatively expensive compared to some other technologies, but it's certainly being deployed, and we see a lot of promise there.
Thanks, Ben. And maybe we see with the fuel cells a similar dynamic as we have seen with the batteries, where the mobile devices let the whole dynamic, and maybe we see from the vehicles using fuel cell technologies also a spillover to the stationary. Well, we're open for that. David, not to forget you, your obstacle view, you mentioned already a few, and I would also pass on the question which Luc Pelkmans raised. What about a CO2 price? Is this for the European situation like a game changer for the renewable gases? Just for you to comment on. Thank you.
Thanks. Well, actually, yeah, this also gives the opportunity to reconnect to some of the previous speakers. If we should carry out this kind of analysis, including the CO2 issue, in the frame of the energy transition. So let us assume that IEA forecasts will be materialized. That's a matter for another discussion, so I don't want to end, but let's assume it. Well, the latest IRENA reports were indicating electricity from PV and wind at approximately down to 2 cents per kilowatt hour. Okay, so it's extremely cheap price. That's why I do not see much opportunity to produce electricity with biogas. I don't see the economic condition, and there are other, apart from balancing that you mentioned, Uwe, but do not forget it requires a different kind of regulation and contribution, which is not yet in place, and it will take some time. So where the income can come from? From the carbon. That is exactly the point. In this moment, we are working to develop what is called an innovation deal, which is a challenge, is a way the Commission has to address non-technical barrier. One is valorizing the CO2. The CO2 market in the regulated mandatory market is quite attractive. It is 50 to 60 euro per ton of CO2. The problem is how to transfer this value into those that can generate the removal unit, because the free market, the voluntary market, is down to less than 10 euro per ton. And this does not make doable to develop a technology and implement it. So that's the reason why we're working on that point with the Commission, exactly to develop a mechanism that can give a possibility to transfer this value to the farmers that generate the contribution. my perspective is that this can be a really game-changing case if it ever happens. It has to be regulated probably by the member states or the countries. I'm referring to Europe. Sorry, I forgot to clarify. That's a point, very important. But it has to be regulated because the CO2 market is a kind of balancing between offer and demand. So you have to keep this balancing in the right shape. Otherwise, the value of your products could easily fall down. That's one point. The other point that is emerging, and it's very actual, there's a discussion ongoing about pricing the carbon farming work. In last week, it was on web and on many newspapers from Brussels. But there is one point strongly emerging, which is the persistence of this carbon. That's why I insist on the biochar to start with this argument, because if you look from the agricultural perspective, that's not an issue. I mean, organic carbon is well placed in the soil, generates microbial life. That's okay. But if you look from the carbon removal perspective, from the atmospheric point of view, then I would suggest let's start with the long-lived carbon sequestration approach, because that's the only way that is safe and can give the possibility to open a strong discussion with the policymakers to include these issues in the regulation. This means that then, and I conclude that the biomethane plant will have two sources of income. One is the biomethane itself, or biogas, but mostly biomethane in Europe, and the carbon with the nutrients in that. That would be a way also to reduce the pressure on the incentives to the biomethane, because, and that's my last point, biomethane can be done, at least in my country, because there is a policy providing a strong economic support to biomethane production. Without this, here would be complicated to develop the biomethane route. We have a good support, and this allows to do this job. So this could be balanced with the recognition of the carbon that is also sequestered. So it's a mix of things, and concluding, CO2 or carbon, as I prefer, will really could really be a game changer in the economics of the value chain.
Thanks. Thank you, David, especially for pointing out this link between the biological carbon and the sequestration options we have, and the permanence, the issue how secure the storage is, and the biochar can be a product of the digestate being processed further. We heard this morning in the presentations on the technical section. So there's a whole variety of options out there if we get the regulatory system right. And thanks also to Sam for pointing out this issue, that the understanding of these complex mechanisms behind the biomass and biogas and biomethane, and now even with hydrogen, comes up. But we also have to bring in this carbon accounting logic. I think that's very, very, even if it's very complex, but maybe we have to demonstrate and be more educative in that sense. A lot of tasks for the GBEP and for IEA Bioenergy and for the national research centers in the various parts of the world. I think that's good when we collaborate further on that. Okay, so we have clarified the integration on the energy market side, the balancing of variable renewable energies, which may be well, and they are cheaper in the moment, and they may continue being so in the near future, which on the other side enables hydrogen to become more or less competitive, which then could help boosting the biomethane options. I think that's also an interesting link we may want to follow up. I guess we have in the F&A section, in the question answer Q&A section, covered pretty much everything which was raised. Again, I would like to highlight the issue, David, you mentioned, at least for the European system, and my understanding of the Californian system and the Japanese system for emission trading of CO2 excludes small-scale users, right? So they cannot really participate in the benefits you may have from trading, even if they're emission savings may be substantial if they are aggregated. So clearly that is an issue we have to continue looking into to make this more attractive. And my question to the colleagues in China, I don't know, Mr. Dong, if you are aware of the pilot emission trading system you have started to work on in China. Is there a link already made between the carbon sequestration from the renewable gas side and the emissions you have from the fossil systems and other systems? Is it already there? Direct question to you.
Thank you. If I understand correctly, you ask the fossil fuels link with what? With the
oh, sorry, you have something like a pilot emission trading system where emissions from greenhouse gases coming from the fossil or coming from the geogenic sources like cement get a price and they trade. And in Europe and in California, we don't have this connection to the small scale biogenic users yet. And I was asking if maybe you have something in China where you look into this.
Yes or and no. You know, in China we started this kind of we started the emission credit.
Yes.
The emission credit. So every the big company will receive a credit. So you cannot emit much more than your credit. But if you emit lower than that, then that credit can be traded. You can sell to the other company. This is for the very big emitters, not a small one. Last year we started for the whole country this kind of trade, the emission credit trade. And this year in Beijing we established a new trade center for the emission reduction credit, the emission reduction credit trade, but they just tried and not put in the full use. On the other, the number 3.3 thing is that we in China we have a regulation for a company. If your emissions is too big, you want to buy the emission reduction credit, then you can only buy your emissions 5% from outside your company. So that means the government required the company itself to really reduce their own emission. Not only you emit too much and then you generate a lot of money and you buy the credits from other resources. Only 5% is permitted. So this is this year there are some very interesting things. So for the very big steel company or aluminum AL, that's a metal AL company. This is a very big emitter, but they can only buy 5%. So it's not enough. So then they try to install the PV system, the electricity, to replace the electricity, huge consumption of the grid electricity. And also they invited the Agricultural University to join to try to find a new way for the carbon fix. That is why I got further information. Okay, the soil carbon sink could act well, but if you have a good land management practice, otherwise you put the carbon in the soil and then you plaster that, and then the carbon dioxide emit again. So that is the situation. And for the biogas plants, for the medium or larger size biogas plants, we are thinking to do this, to contract several biogas plants into one virtual company, so that we have a higher emission reduction credit, So we are qualified enough to compete on the trade market.
Very sensible. Yeah, very sensible.
During just under the consideration. So I communicate with the biogas sectors and many biogas companies. They tend to do that to give their carbon emission reduction credit trade right authority to my hand or to a company hand, and then for that company to do the trade on their behalf.
Very good. Yeah, thank you. Michaela, when we take the global view again, we just had COP26 and people have very mixed feelings about positive and negative outcomes. But one thing, at least, we learned, the Article 6 of the Paris Agreement, which means the international collaboration in implementing emission reductions and things, is now more or less ready to take off. Is it something you see that countries such as Vietnam, where there's a lack of capital for biogas plants, and others where we have lots of money, but and a lot of emissions as well, I would include the Europeans here, that there is more collaboration coming up? So as we did in the pilot phase from the clean development mechanism, which was always more or less voluntary, but now we have something under Paris which seems more solid. Is it a positive thing, you would say, in addition to the emission pricing?
Yes, I would say definitely yes, because it gives also a very strong political message and way ahead for countries. So it's a kind of political push to a stronger collaboration in that sense. Absolutely. And also it's also a way of increasing the attention of governments of countries to include energy and energy targets into their NDCs, to include also commitments into their national strategies regarding SDGs and SDG 7 in particular, so energy access. So it's all bioenergy. We know that bioenergy is a very cross-cutting issue. I mean, it touches upon many aspects of our day-to-day life, and it can only be addressed in a holistic manner. And that's the way how in GEP we have addressed the sustainability of bioenergy value chains, looking at the various aspects of sustainable development, not only the environmental aspects, not only the social, not only the economic, but all together under the same umbrella. And if I may, connected to COP26, we have received a very strong new message, very important message, which is related to methane. So I read one of the questions in the chat, and I wanted to use the opportunity to reply directly from panel. So this message from COP26 regarding methane reduction, the importance of methane reduction, is extremely important, and extremely important for the biogas sector itself. Why I'm saying this? Because of course we know that the methane capacity of methane, the warming potential of methane with respect to CO2 is 28 times more higher in the short term, that goes up to 80 times more in the long term. So it means that if we think that methane has the potential to reduce GHG, the warming effect, and therefore to reach the climate targets, we could contribute from the biogas sector. How? With the example that I made regarding the palm oil mill effluents, with methane emissions that otherwise would have gone up into the air as a waste and as a pollutant, but otherwise we could instead capture that methane and produce additional energy for energy use, efficient energy use. Thank you.
Thanks, Michaela. Just for clarification, the short-term global warming potential is higher. It's the 80 figures, and the longer term is the 30 figures. So you put it the other way around. But I fully appreciate your reference to the methane pledge. I think that's something which I could actually, Malcolm McDonald is now working on in the European Commission, one of our missing panelists here. And he's quite busy trying to come out with a European methane strategy, which hopefully brings the issue more round. Two questions I saw in the question and answers we still have to address. One is related to the methane. When we assume there will be a more deployment of biogas and biomethane technologies and also hydrogen in the longer run, what about the methane leakages? On the one hand, we can offset, like you mentioned, with the POM from the palm oil, and there's also the manure and others. But on the other hand, if we maintain leakages in the digesters, leakages in the pipeline systems, we may have a problem. So is it something where the biogas, biomethane sector has to do its homework? And then we have one other question, just maybe you think already in the back of your minds about an answer, the question of the potential. So how much is there out there? Is it actually making a dent in the climate game, or is it just something small? So that was a question, and maybe David, you have seen the question: how much of the energy in the feedstock is actually converted into a useful energy? So just don't have to answer right now. We go around. So the first question is this methane leakage thing. I can imagine that an international investor will shy away from biogas if somebody says, oh, it's going to be leaky. And Sam, you mentioned the debate we had in New York State exactly on that, where people claimed that there is no net gain from bringing biogas into the system. I would start. Yeah, please.
Can I ask you
David,
just
go ahead.
to add another point? I fully agree on all that you have just said. I would only like to add one element for the discussion, the time frame. I mean, we are not making a theoretical study on what is better and how much, but we have targets 2030, 2050. We have to implement solutions at large industrial scale to deliver volumes of savings, energy, whatever. So our discussion cannot be carried out without taking into account the options that we have available, technology, infrastructure, economy, many elements, but all together in this time frame, because this constrains the discussion around a small set of solutions. The risk is to be attracted by very nice technology. As a researcher, I'm fascinated by innovation, but I also know that it takes decades to bring technology to scale and to replicate in large volumes. So we would fail the targets in that way. So our discussion should consider also the time that we have to available to implement those solutions.
Very good, thank you. I understand you in that sense that even if the potential for renewable gases in the moment, at least from the biogenic side, has a certain limit, but it's ready to use. All right.
I mean, yes, exactly. I mean, we should think in terms of roadmaps and development of a route to our targets, on which I think we all agree. I mean, there's no discussion about the targets. The point is how to get there, and probably we will have a set of options that now maybe are to be preferred because they're ready, and maybe tomorrow we could shift to other more efficient solution and to deliver a roadmap to get there. This is exactly the difficulty that I see in scenario development.
Thank you. Sam, you have a view on this methane leakage thing? Is it?
Yeah, thanks. So I think, one interesting aspect of the leakage conversation is that, we know that the current oil and gas system is responsible for a large amount of methane leakage, but with biomethane, RNG, renewable hydrogen, I don't think we're talking about replacing that entire system with these gases, right? So inherently in that, you're not going to have the same amount of leakage that we would now That's not what we're suggesting, right? I think the best we can do is reduce methane leakage as much as possible, and then implement CCS technologies that would still be able to offset that small amount of leakage that's there, and still bringing the industry to carbon negative overall, which is really a great outcome, even if you had small amounts of methane leakage within the system. One of the issues we've run into in the US is that there's no really up-to-date data on what actual values from leakage are. So recently, there was a Danish study released. I believe their leakage that they came up with at the facility level was 2.5%. I've been in conversations in the US where folks have been suggesting up to 15%, which is, really inaccurate. And I think some of that stems from studies which are literature reviews and which have been released recently. So really our challenge is we need better data. There is a study forthcoming in the US being conducted by Colorado State University, which they're really regarded as top experts in the US on methane leakage in developing both the methodologies and the existing reports that do a really good job of outlining methane leakage from our current systems. So they're developing a study for the RNG industry, which I think will be really telling. So ultimately, we need to reduce the leakage as much as possible, and we will be dealing with a smaller gas system likely in the future. And again, with carbon capture and storage, it's still very possible, and I would say likely, that we're able to achieve a carbon negative emissions profile overall. The last piece of this, which I sort of glossed over, is that when you look at current methane emissions from biologically derived sources that we're dealing with, I mean, it's a really massive problem. So how would we justify not capturing the methane? Because there's going to be a much smaller amount of leakage within the pipeline system. I think that's an important aspect of this to consider, and it really goes back to David's point of what's available now, and we can't let the perfect be the enemy of the good.
Thank you, Sam. And with the methane pledge, which was mentioned by Michela as an outcome of COP26, plus the activities we have in Europe going on with the methane strategy and the UN system, which looks also into improve the monitoring. We have now a UN monitoring system, fortunately, for the methane. I think we will improve on that. And as far as we know, the major leakage component comes actually from production and conversion. And the other one is on the distribution side. So if we can use on-site production in smaller, medium-sized systems and make use of that, or feed it into the system for the gas transportation, for the biomethane for transportation, we also have to consider the leakages, but we can improve on that because it's new systems. I think that's a major benefit we see here. We don't have to go to leaky old gas extraction sites. That needs to be cleaned, no doubt about it, but that's not necessarily the job of the biomethane industry. In the chat, there was the discussion, as a point made, what about synthetic methane? And I think we have the same debate here, if the system needs to be cleaned up in the near term to reduce the short-term climate forcing from methane coming out of the natural gas system, then we can use a reduced system, an improved system also for renewable methane. But in my view, it will be very different from the system we have now. In terms of distribution and the amounts of natural gas or methane we're gonna distribute, that will be very different from the levels we have now. Michela, you wanted to react. Did I see that right? Okay. No, then we go ahead. We have the question of how much do we have in the near term and not by 2100 in the next couple of decades where we really need to reduce to become carbon neutral. We learned, Mr. Dong, from China that there is the ambition now to become carbon neutral by 2060, which is really, really good to hear. Do you have an idea how much the renewable gases will play in that game? Will they have 10%? Will it be 5%? So could you give us a flavor of the order of magnitude of the renewable gases in China in this longer term period?
Thank you for the question. Yes, China, this is a national strategy that by 2030, as we call the carbon peaking, and by 2060, this carbon neutralization. And this is a national strategy, and China promised it to the world and repeated the promise for about 10 times already by now. Yes, for the renewable gases, we have a calculation about how much agricultural bio waste we generate right now, and how much is could be used for the biogas production. For example, the crop residues, now about 50% is just returned directly onto the field to try to keep the soil organic content, to increase the fertility or increase the soil healthy. And for the manure, we have to return all of the manure into the field, but most of that is half of that is treated by the composting, and half is only 10%, 10 to 20% is treated by the biogas technology nowadays. So we analyze that, and that's why I raise the suggestion to the society, every bio waste we call it biogas first. So to put all the possible bio waste into the anaerobic fermentation, to convert the carbon into the energy, and then the residue from the AD, that is the hard to degraded carbon, and then we can return into the soil. So I try to convince the society that if you just return the crop residue directly into the soil, then the easy degraded things will become the carbon dioxide and methane and emit into the air. But now, if you put into the AD process, we get the easily degraded carbon to the methane, and then the hard degraded carbon keep in the soil. So that is so finally the carbon in the soil is the same, but from the AD process we get the biogas. So I have some article and a calculator try to convince the government society to follow this way. And now I'm pretty successful that more and more people in the agricultural ministry, they like the idea. So that is a good thing. So based on that, we calculate, and by the 2060, there will be 50 billion cubic meters of biogas from the crop residue, and 70 billion cubic meters of biogas from the animal manure. So totally, that's about 120 billion cubic meters. So that is a very high amount. That is about 70% of the current natural gas consumption. So that's a very big contribution to the natural gas, to replace the natural gas. Yeah. But we know that the from the bio waste to biogas, if we even put every molecule into the biogas, the biogas energy is not enough. It is only about 10 to 20% of the overall energy consumption. So the biogas itself, only one type, the energy type is not enough for the climate mitigation. So we need a different kind of technologies.
Thank you very much. That was very clear. You may have noticed that David had to drop out. He has another meeting coming up in 5 minutes, and that's our time scale anyway, so he had to run. Sorry for that. He was, I think he's available if you want to. You can check his presentation for details, and if there are questions, He, as well as the other panelists, are available, and we encourage you to take a closer look to the presentations and contact info, which will become available latest by tomorrow in the website from the IAA conference for this session. Michaela, you have the opportunity, I may say, to give us a way forward. What are the next steps in terms of green gas from your point of view, from this global thing? We have this tons of hydrogen strategies. Biogas and biomethane have been maybe a little bit lost traction for the policymakers at least. But we heard from Mr. Dong, biogas first. I think that's a strong message, right? Maybe we should take it up. Is it something and also the educational component Sam mentioned, we have to explain a lot. So what do you think? What are the next things to move ahead?
Thank you for this opportunity, because really biogas has incredible potentials. It's underused, underestimated right now, but it has huge potentials, and those huge potentials are from the rural areas, the smallholders areas, where through the measurement of the GWAP indicators, we've really touched with our hands how underestimated it is at the rural area, because there are enormous potential, but not yet used in a very efficient and complete manner. So it means that a lot has to be done still, but it's also true that the international attention around biogas is increasing and increasing, which is very good, because then we have the opportunity to take out the best from the positive factors of biogas, and this is perfect. This is the perfect connubo regarding how we could take out the best from the opportunities that bioenergy could offer. It's important to take the momentum and support countries with their policy measures, with policy incentives, trying to incentivize the sector in at all scale in all countries, and improve trainings. This is key as well. This is my main message. Thank you.
Thank you. Sam, you already mentioned education as a job to do from the Northern American perspective. Closing remarks from your side in that regard or beyond? What are the next steps?
Sure. Yeah, thank you. I think the next steps, as I mentioned in my presentation, we're very heavily in the transportation sector now in North America with renewable natural gas as it is used in natural gas vehicles. And I really see the next step as going beyond that and exploring more deeply, which a lot of jurisdictions are currently doing, but exploring more deeply the use of biomethane, renewable hydrogen at some level to transition the existing gas system to carbon neutrality. And again, I think that's in tandem with other technologies, right, like electrification and efficiency, but that's really the next step that we're looking at. And just to make sure that we're expanding life cycle accounting into most programs, right, so that we can actually evaluate correctly these resources and their potential, even from a cost benefit analysis perspective, to incorporate wider sustainability benefits that we can realize in the waste management sector.
Excellent. Thank you. So we are reaching the end of this session. Thank you, dear speakers, panelists. Thank you for the participants in raising questions and comments. I guess we have a lot to reflect on from this green gas session, making what we heard in the morning on the emerging technologies, what also Mr. Dong told us about the Chinese view. I guess it's really, really important to have this integrated view that we say the renewable gases are not alone. They deliver co-benefits in environmental, but also, as we heard, in rural deployment income, where a lot of regions suffer in the moment. And the message, I guess, we had from David, take the low-hanging fruits which are there and don't wait for the wonderful stuff we get by 2050. We have to act now. It's a decade of action. That was what we heard. And green gases, biomethane, biogas should be part of that. And with that, I leave you for the next sessions you hopefully attend of this wonderful conference. And next week when we close, some of the messages from this panel will be conveyed and hopefully be taken up by the audience. With that, thank you so much. Have a great day, afternoon, evening, whatever, and see you soon. And we're gonna do it. Thank you.
Thank you so much.
Thank you.
Bye.
Thank you.
Thank you.
Thank you. Very good to see you. Thank you. Bye-bye.